My name is Ixchel Ruiz. I'm from Mexico, live in Switzerland. I'm a Java champion. And that photo is from JCREAT. I'm very active at different conferences around the world. That's one of my passions. I also do a lot of community work and organize conferences. So this is the first time as I'm a speaker here in JFocus. I attended this conference several times before, and it's one of my favorites. And my suggestion to you, if you ever want to start with sessions or giving sessions, is you don't have to be an expert. Sometimes it's a good idea to present our WORA battles, and this is one of it. So integration tests. Every person that does a session about integration tests usually shows this picture. And it speaks volumes. I mean, good plan, bad execution. But I'm going to talk about another kind of problem. And it is very important for me because it shows how expensive sometimes things are. For example, this is the LHC in Geneva. And this is the testing facilities. As you can see, well, it doesn't look the proportions, but this is a huge building. And here you can see 5 dipoles. So remember the LHC was closed in 2008? Well, it turns out that there was an explosion between the connection of 2 of the accelerator magnets. And in that explosion, they lost 24. No problem. They still have 30 in storage. What's the problem? Because this is kind of a very big project. The company that actually created the magnets is not longer working on that. So they cannot build more dipoles. So they, or the CERN, doesn't have the room for any other error. And let me remind you the problem. The problem was the connection between the 2 containers, or the 2 dipoles. And as you can see here, in the testing facility, that was exactly the problem. They can only do unit testing, never integration tests. So for the CERN was 2 years close, and the tab was quite high, around the tens of millions. So that's, for me, a good example of integration tests. At this point, I think we all have worked with containers. They started appearing 3-4 years ago. I remember when I was attending conferences and I was listening to Docker containers and then orchestration. When we started in Java, there was a promise, and it was amazing. Write once and run everywhere. When containers came in, we have a different promise. With containers, we can package once and deploy anywhere. So that's quite neat. And also, containers allows us to, or help us in different aspects of our development. During development itself, production, and test. We are going to take, this story is going to talk about the 2 aspects, development and testing. Now, a little bit of the description of the project that I told caused a lot of problems. This was a Spring Boot application on the server. We had 2 web applications with Polymer, 1 desktop application with JavaFX and Griffon. We were using in production Postgres 9.4. And when we started this application, the development of this application, we started using H2. We had a customer almost at the same time, very early. So we were developing some features while the user was testing our application in almost production mode. So we were in a continuous loop between the development and production. One of the things that we first encountered was H2 is really nice for development, for testing, fast testing. It's really nice. It's an in-memory databases, has a really nice integration with the Spring Boot. It's really easy to set up. The problem, it was not Postgres. So when we start deploying our releases into the customer environments, he had 3 customer environments, one for quality assurance, testing, and integration. We started noticing that there were some issues. Granted, most of them were our issues, but still, going and releasing the product and installing in the customer environment and figuring out at that specific point in time that we had a problem, it was too late. So it was not acceptable. So we said, no, we're going to start developing as close as production. I mean, at this time, and this should be like a rule. And then, granted, again, we had some troubles with my fellow developers. Some of them didn't want to install locally a Postgres database, which is weird, but anyway. So what we did is, don't worry, you don't have to install locally your database. You're going to install it inside a Docker container. So we pass around in the README file of the application how to start your own Docker container with Postgres. This is super known at this point. Later on, I started using Docker Compose because we had to start other containers, and it was super nice at that point, like 4 or 5 years ago, that we could also start starting different services in different components. So it was super nice. Everybody, even we check in the Docker Composer file, everybody was able to use it. So setting the developer environment was super fast. We were all happy. As I mentioned, our client had 3 different environments, and he had 3 different configurations for the databases. For example, he had different logging for transactions, the sizes, and the rotation. So again, we were almost happy. We were working, obviously, in our environment, in our test environments, and deploying into their first level of testing. And at that point, when we went to the second level of testing, or their second environment, we noticed this mismatch. So we were like, okay, we have to now run our test locally as developers, run our test with the configuration of the different configurations of the client. So what did we do? It's interesting, in the previous session, they were mentioning this book. I totally recommend you to read it if you haven't. And so I'm going to go a little bit into some of the concept of DevOps, really fast. When containers started to be very popular, a lot of people learn about huddle versus pets. And Martin Fowler actually coins a different one, Snowflake servers versus Phoenix servers. So the idea behind it is to have, avoid having Snowflake servers, which means you have a server, you start installing patches, security configuration, security patches, updates, or any kind of thing that is going to alter the state of your server, and suddenly it's not reproducible. Suddenly nobody wants to touch it because nobody knows how to keep it in that state. So this idea of creating everything from scratch, having everything exposed as a configuration file. And just mixing and matching, it's really important. So that's exactly what we did. All our security patches, all our configuration, it was exposed, well administered with versions, and we were creating, granted again, we could have solved in a different way because you can load a volume with a different data, you can load a different volume with different configuration. So probably it was an overkill, create different versions of the different environment, but that's what we did. Right now I'm going to show you the whole gamma of Maven plugins and Gradle plugins that we use. Actually, I'm going to show you the examples with the Gradle plugins, but there is a similar option in the Maven world. We started with the Gradle Docker plugin. This was created by Benjamin Mushko, and you obviously install the Gradle plugin, and you can create your own images. You can specify the different, how to create them, you can tag them, you can push them to your local repository. So that's what we were doing in our continuous developer continuous integration. As soon as we receive any new configuration of security, granted it was not so often, we will generate new Docker images with our databases or different services that we require from our customer. So we were happy. We could create Docker containers easily, and we could run them locally in our business analyst machines, or locally in our developer machines, or in CI on CD. So we were happy. To add more drama, and actually this was the dramatic part of the project. As I said, we were running, well, the client was running production-like because he was evaluating our software, and well, we still developing. So there were a lot of changes into their business model. Let me put it like this. We were developing an application for a bank where you have single accounts, joint accounts. It doesn't matter if it's a physical or corporation account. When we start talking to this new client, suddenly we realize that we were working with a bank that had different traditions. So instead of joint account or single account, suddenly we had a person that could have a lot of wives. So yes, that changes your model quite a bit. So we had to use Flyway. Or well, we didn't have to use Flyway. We could use Liquidbase or Flyway. In this case, we went with Flyway for migration schemas. Why we did that? Because it allows Java for creating the migration scripts. I totally recommend you to have a look if you're looking for a migration schema tool. It's quite versatile. And again, let me introduce this scenario. When you are running tests, you usually, well, the policies is have them really isolated, have an initial state, do some transformation, and verify that the final state is correct. That's a good test. We needed to test something different. As I said, the customer was already production. He was already introducing rules, business rules, because this software was particularly very flexible. He was introducing data into the database. Suddenly we needed to change the model, the domain model. And we needed to migrate their data from the previous version of the database to the new one. So we needed to test that our migration scripts not only did the right thing at the schema level, so we needed to test that after applying the migration script that migrated the schema and also migrated the data, because they already had data, and we couldn't say, you know, with this version, we're going to delete your database and that's it. No, what we had to do is, with this new version of our application, you are going to, back up your database, start the application, migrate the schema of the database, we will take care of the data, and that's it. You are a happy customer. So this was our second concern. How on earth we could assert that the migration schema and the migration of the data was successful? We didn't know what was the initial state. Who knows what the user was adding into the system? So we couldn't assert quite easily. So what we did is create some kind of services to verify in a more or less with high chances of success if these services were run, checks into the databases to verify the consistency of the data was correct. So now we were asking our client to provide us with a copy of their production-like data. We were going to initialize our test database containers with that data, run our application, verify that the migration scripts were run, and where the database at the end will be in a consistent state. Of course, if we had a problem with a migration data, guess what? The database is inconsistent, and probably we trash that. So we couldn't wait until the client said, you know, installing the new version or the new release, it's wrong. Again, this is easily solved. You get your volume, you put the data there, you run the initializer scripts, and that's it. We even had now the server side running in a different Tomcat in a Tomcat container. We could even use it with the Gradle Docker Compose plugin to run our integration tests. And one interesting thing that the Docker Compose allows you, the Gradle Docker Compose, is that before your tests are run, you can invoke compose up and compose down. That was fantastic. That actually solved our problems. Sometimes, and you may have noticed, that you start running your tests and the Postgres was not ready. The container was starting, but the ports were not ready, or the database was still not accepting the connections. At that point, we learned of wait for it, which was super nice. We were waiting for the container to be listening in the port 5432. Now you can also use health checks, which is nice, so we were happy. This works in integration tests locally. What happens if you go to CI/CD? You have port conflicts. Remember, in my Docker Compose, I was exposing very specifically a port. There is a solution, the Docker Compose plugin. The Docker Compose plugin allows to expose as environment the different ports, IPs, even the names of the containers if we wanted to remain them anonymous. That was perfect. We thought that we were there. Everything was running perfectly. Except when we were looking at the documentation of this particular plugin, we noticed that they had force compose down. And we were wondering, why do they force a compose down? Later on, we discovered sometimes we had zombie containers still there because the test failed or something happened. The other problem was the configuration was different. As you saw, we were exposing as system properties for environments the configuration of the ports. They were anonymized, yes, but we still need to change that. And that meant we were changing our application properties for our Spring Boot application. So 2 cons, 1 pro, we're almost there. We discovered testContainers, and that changed us. So with testContainers, you have automatic discovery. In the example, you will see why I'm so happy about it. It automatically pulls down your Docker files. It starts and stops the containers, but quite nicely. The life cycle of testContainers is interesting. testContainers will orchestrate different container, so he will take care of all the containers you are requesting. So no longer Docker containers that are zombie. Even if the test fail, he will do the cleanup quite nicely. So now even on our CI/CD servers, they were still behaving correctly. Because in the order option with the Docker Compose, from time to time, our IT department will call us and, Ixchel, you have like 10 containers running. And we were like, oh, we should kill them probably. The port mapping, it's really easy to set up. It has a JUnit integration. It really maintains the instances isolated. As I said, it has a really nice port randomization, and you can use tags. And there is support even for Scala, Python, or Java. So let's go to the demos. I have several ones for you. And sometimes I really want to make the examples as compact and concise as possible. So I'm really happy when they can fit all the example in a single page. Okay, so for those of you who haven't worked with Groovy or the Groovy Console, this is the Groovy Console. So this is the entire content of my test. I'm using the dependency manager with Graph. So this is only the dependencies I'm using right now. I'm using the latest version of testContainer. Don't pay attention to these two. This is because of a conflict between the version that we're running and the Groovy Console, so that shouldn't even be there. So I'm using, rest assured, I'm using testContainers Groovy script, and I'm using the testContainer 110. What I'm going to generate, it's a generate container. testContainers already provides you with a lot of modules. For example, databases, really useful. Web drivers, you can use Nginx, Selenium. So very interesting what you can do. Well, let's go back to my example. Yesterday, I was giving another talk about OpenAPI and how to create mock services with WORA mock. So somebody asked me yesterday, Ixchel, have you used any other tool, for example, for creating mock servers from your OpenAPI specification? And I said, not yet. The one that I use is WORA mock because it's a Java library, and I'm very, very comfortable with it. But that question made me think. So in this case, I found out a tool written in Go that actually did that. You provided OpenAPI specification, and he will generate a mock server. So the application, the tool is called API sprout, and the author provides a really nice container, already a Docker container. So maybe I should show you the documentation, API sprout. Yeah. Sorry, I was looking into the issues. Okay, as you can see, it's really super simple. What he's doing is either you run it locally, point to the API that you want, if it's an URL, or you run the Docker container exposing port 8000 and with the URL, or, and this is the important part, you can mount a volume with the OpenAPI specification into a specific location and then run a command. So we're going to do exactly that. So yesterday I was creating that. I use a generic container. I configure with what exposed port I want to use. Look at how I'm mounting a volume. So that's quite interesting. And you can also specify that the container starts with a specific command. And there are even different strategies for waiting. In this case, I'm waiting for the URL pet have a status code 200. And if you let me show you all the different waiting strategies, because I think it's really interesting. So for example, if you are expecting an URL, an endpoint, you can even wait for different status codes. You can check for health checks. Some of the containers have already predefined different health checks, or for specific log messages. So they are quite convenient. In this case, we're only waiting for the URL to be there and has a status code 200. Before class, I do API sprout start, and after class in the teardown, I stop my container. And this is quite simple. Let me show you what we are doing. There you are. So what is actually, it's not showing very well, and we will see it in the Postgres container. You will see in IDEA, in the console, how it's going to start the Postgres container, how it's going to expose all the ports and variables, etc., etc. In this case, it's very, very simple. It's actually, see, waiting for 60 seconds until I don't know which port and my endpoint pet is there, because that is the beauty. Here, I'm using rest assure. Remember, this application is going to create a mock server, so I'm going to verify that it's there. In this case, because of its convenience, I'm using rest assure. It's really interesting if you want to give it a try. So what I'm doing is I'm doing a request of application of type JSON, and the port. Actually, when I'm starting or declaring, it's actually at the point of a start. When I'm starting the container, I have a bunch of properties. And one of the most interesting, obviously, because we have random ports, is what is the map port. So my rest assured, well, my test is actually connecting to a specific endpoint in said port and sending username and password, and then waiting for the status code to be 200 and verified that the body has name. So in this file, what are we doing? We're starting a generic container. We are verifying with rest assure that I have everything there. I'm going to uncomment this so you can also see what are all the properties exposed by my container. which are quite long ones. But you can see that I can also get the IP. Let me go to the IP. I can also access the logs, the exposed ports, the first map ports, the network aliases, etc., etc. And you can also even configure that when you are creating your generic test container. So that's quite interesting. And it's quite easy. Okay. Second example. And here, wait a second, I know how to increase the size. View, increase the size. No. How do you increase the size? Okay, okay. That's one way. Okay. Perfect. Okay. Well, this is not needed. This is one of the most standard tests that you can see for MySQL container. Actually, there are compact ways of doing this. This is an example I took from the official documentation. I have used, as you saw from my story, the Postgres container. But I wanted just to show you this very simple one. So in this test, I'm starting a new MySQL container. I do a start. I'm manually configuring the Hikari configuration, which is optional. It's not the only way to do it. But this is the important part. For testing purposes, does it matter to know what is the database name? No. Should I set it up? No. I only need a MySQL with a specific version. In this case, the version that I'm using, oh my goodness. The version that I'm using, exit presentation mode. Sorry, I'm going to return. I would just want to show you the my version is, I think I'm using 8. But let's go back here and go into the presentation mode again. So it doesn't matter. It doesn't matter what is the username. It doesn't matter what is the JDBC URL. It doesn't matter what is the port. And as you can see, I'm actually asking those properties to the MySQL container. So for me, they are totally irrelevant. And I only need to have them. In this case, we are not changing the ports. It doesn't matter. And, well, if we run the test, obviously. And here is what I wanted you to see. Well, it's going to be green. But, excellent. How do I show? Yeah, sorry. Yeah, no, super nice from. Okay. Well, you will have to believe me because the output is being sanitized here, but you can see how the MySQL container is going to be started. In this case, the only thing that it's going to give me as an output is this. The test containers will make sure that you're running the specific version of Docker. It will take care of all the environment. It will be discovered and sent to the different containers as properties. You can access them, as with the example with the API sprouts. Let me show you other examples that I found really interesting. If now you compare, this is the configuration from test containers, and I want you to view. Okay. Yeah, this is it. that you compare how similar is performing a query with a Postgres container. It's actually the same one. You start a Postgres container, and in this case, they are doing the perform query, and the perform query is exactly the same. They declare a new Hikari configuration. They also pass a JDBC URL, the username and the password, and they execute the statement, and that's it. So if I wanted now to have my test case run against as SQL, a MySQL container versus a Postgres container versus a Microsoft SQL server, it's quite simple. I want to show you the MySQL. So, here it is. And for action, wait a second, network is not working for me. And we actually did that for our product at the end of the day. Well, this is, but as you can see, it's the same thing. Here they are declaring as a rule, so you can be reused in the different tests. And again, the same exact content of the test. And if we go back to our Groovy console, you see that you can execute different commands. You can mount volumes with ease. You can have different strategies for waiting. You can configure or request specific exposed ports. You can even create Docker from a Docker file. I mean, you point to a specific Docker file. It can be even a not a really built already in a Docker repository image. So that's even how powerful this tool is. What else? The last thing I want to show you is the other. Oh well. This was a surprise for me. They even have for Oracle databases. The Elastic container, it's also very interesting how you're using it. Yes, now I remember. This is really interesting because it can reduce your headaches. When you look into the documentation with class path resource mapping, you see here a file. This is local to, actually the documentation literally says it cannot start with a slash. So for me, I had to go into the Java documentation to notice that. So don't use file path, use a file. This, it doesn't have any restrictions. It can actually be a full absolute path inside the Docker container. And there are different bind modes, but that's equal to any container. So, what else? We are in release number testContainers Java. There is a version for Scala. We are release 1.10.6, and this is the latest released. I really suggest that you have a look. It removes a lot of headaches. It's powerful, it's flexible, and it has a lot of support in terms of in the forums or in the web page. With this, I leave you. Thank you very much.